So in this video, I'd like to talk about the Fourier's diagram for Coulomb's law. So first, let's go through the definition. The force of attraction or repulsion between two electrically charged particles at rest is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. It is better to illustrate this definition with the equation, which is F is equals to, so this one is a constant, and this is actually equals to 9 times 10 to the 9 and m squared per c squared. That is the unit. And then we have the charge of one particle, or the test particle, the source particle, the distance between them, and this r hat is referring to the direction of the electric forces. So it's better to illustrate the direction with diagrams. So in this related halfway diagrams. But first, I'd like to talk about the applicability or limitations on using Coulomb's law. So whenever we're using Coulomb's law, we're assuming that the two particles are at rest, so they don't move, so the r is constant. And because if we are changing the r, then the force will not be constant, and we have to measure the force at every different location. And then another one is that it is with point mass or point charge. So because if it is not point charge, then we can't really calculate the electric forces between the two objects. So when we're using Coulomb's law, we're assuming that it is a point charge or a particle. So this is the diagrams. So we're always when we're talking about distance, we're always saying that it is from a source particle to a test particle. So this one, F, would be from Q prime to Q. And this one, same thing, Q prime to Q. So we're talking about the electric force that is due to this particle. By the charge model, so the same charge repel with each other. So intuitively, the electric force would point towards this direction, but we could prove with our Coulomb's law. So because both charges are positive, so this component here is positive. And then so the only direction we are considering is this one. So this one is the r hat. And right here, r hat is, so this one is the r vector. So since r vector is pointing in this direction, we're just finding a unit vector that is pointing to this direction as well. So we're saying that the electric force is parallel or in the same direction as this arrow. And that matches. So it is the same thing if we're talking about different charges. If we're describing the electric forces between a positive charge and a negative charge, they exert attractive forces. So that's why that's the electric force, and the r hat is in opposite direction. And that is the first diagram. Thank you.